World's first aircraft with revolutionary game-changing superconducting electric engine was first tested in Novosibirsk. In the first days of February this year, in the Chaplygin Siberian Aviation Research Institute airfield in Novosibirsk was given green light for ground tests of plane laboratory, made on the base of Soviet-made Yak-40. This unique aircraft is equipped with hybrid power plant that includes superconducting electric engine that was exclusively built for this type of aircraft. To say it is just progress or something evolutionary means to say nothing. We can see very clear the start of the development of absolutely new class of aviation, electric aviation, and for now only Russia shows the biggest progress and real working results in this field. Of course, that doesn't mean nobody's trying. There's a number of similar programs around the globe. German giant Siemens has not only a similar project, but even a flying prototype. The problem is, it is ultralight and for one person only, despite the fact that Siemens' one-person jet is surprisingly powerful engines. They are not superconducting, which means they have no chance to compete with superconducting electric engines. European aircraft manufacturer Airbus also works on the development of electric airliners. Siemens and Rolls-Royce together works on the project E-Fan X. It's supposed to be hybrid jet, as well as project Super Oaks. First flight scheduled for 2021. However, all of these projects tend to work with regular electric engines. Besides that, European program Advanced Superconducting Motor Experimental Demonstrator, which is coordinated by German Oswald Elektromotoren, announced development of demonstration version of superconducting electric engine, but is still mystery in which stage of the development process they are, and is there anything working mate. It is obvious Russia is not the sole player in this electric aircraft game. However, in this field only Russia moved forward more than anyone else. Russians not only have working superconducting electric engine, but already use it for ground tests on the actual plane. Russia becomes the first country in the world that tested that type of flying machine in working conditions. In fact, Russians did impossible and unified two projects, E-Fan X and ASMED, into one, which allows to stay ahead of the competition. Plane laboratory Super Oaks is equipped with hybrid power plant and with classic generator, which uses oil to produce electricity. Similar project has Airbus. However, they're using traditional electric engine. Therefore, it doesn't matter how innovative will be Siemens made engine for project E-Fan X, it will still be way weaker superconducting electric engine from Super Oaks. Technology of superconductivity significantly increases engine specific power, so-called power-to-weight ratio, and gives incredibly high energy conversion efficiency, up to 99%. High-temperature superconductors are used in making these revolutionary engines. Of course, that doesn't mean that superconductivity will appear itself in room temperature. No, that means that superconductivity will become possible once temperature will be far more than zero, for example at the temperature of liquid hydrogen or helium, and in the long term even nitrogen. High-temperature superconductors is not something that exists only in someone's fantasy world. No, Russian company Super Oaks a long time in the business and not only works on the development but also manufactures materials and other production retaining substances of high-temperature superconductivity. Company exports production to 20 countries worldwide. Having the most important component needed to build these engines guarantees Russia strong and reliable growth in this area. One of the most complicated parts in making electric engine is to provide cooling for the stator and rotor so that the winding has a temperature necessary for the appearance of the effect of superconductivity. However, it has been found that complexity of cooling the high temperature superconductivity stator is that the cryostat materials will be in the zone of action of high alternating magnetic fields, which cause intense heating of metallic materials, increasing thermal load on cryogenic circuit and reducing the efficiency of the entire system. told Sergei Smolenkov, CEO of the SuperOaks, company which works on the development of superconducting electric engine and high-temperature superconductors. SuperOaks developed a cryostat technology for the stator of an electric engine, which does not contain metal parts in the active part of an electric engine. According to the CEO, rotor cooling requires the development of a rotating refrigerant inlet with a vacuum seal, which considerably complicates construction of the rotor. Besides, this allows the rotor shaft to be hollowed out and to control the variable pitch propeller through it, an important addition for aviation. Despite the fact that NASA in 2007 admitted that using of the high-temperature superconductors in aviation is highly prospective, it is still a completely unknown and unpaved way that can lead to nowhere. Even if it's so, Russia still will be among those very few countries in the world that has its very own high-tech manufacturing industry, able to produce the most complex high-tech productions, and company SuperOaks that works in development and production of those kind of products suffers best example. If you liked the video, be sure to subscribe and ring the bell.